So these are practice problems that go along with the angle sums, the polygon sums, the interior angles of polygons and exterior angles of polygons. If you do not have the half sheet notes that we completed on Friday before break, or lost them or whatever, there's a quick video on that. So if you want to make sure you get this, if you need to print it off the blog, that's fine, or I have some more in class. But come get that and go see that video to fill that out first. You do have that filled out. Here's some practice problems of how we can use those notes to answer these problems. Okay. So number 1 and 2, we have a hexagon. A hexagon is a 6-sided figure. It is a regular hexagon, meaning it has 6 sides that are equal in length and 6 angles that are equal in measure. So a regular polygon has the angles and the sides of a regular polygon are all the same. So a regular hexagon has 6 sides that are equal and 6 angles that are equal. A regular 47gon has 47 sides that are equal and 47 angles that are equal as well. First thing they're asking us here, they're asking us for 4 different pieces of information. The first one is for the sum of the interior angles. So to find the sum of the interior angles, we could map it out in our heads. We know that we can split this up into triangles. We have 4 triangles. We know each triangle, the angles of each triangle. So A, B, and C are going to add up to 180. D, E, and F are going to add up to 180. G, H, and I are going to add up to 20. And J, K, and L are going to add up to 180. So we know we have 4 triangles, each adding up to 180. And that's going to give us 720. Okay, so we can reason it out. That's fine. Or we have the formulas listed on our notes. We can just use the formulas. So the formula we're using here is the second row, okay, and then the formulas we have in the last column. So our formula for the sum of interior angles of a polygon is n minus 2 times 180. N minus 2 representing the number of triangles you can make, and 180 representing the fact that each triangle has angles that add up to 180. So we said n is 6 because it's a hexagon. It has 6 sides, so we can substitute in our 6 for n. So we get 6 minus 2 times 180, okay, which is going to be 4 times 180, which is going to give us 720. Okay, so the sum of the interior angles, all we're doing is using our formula, substituting in n. N is the number of sides. Okay. If you want to understand it more deeply, we can make the triangles and see how many triangles there are. And again, the triangles is what n minus 2 represents. How many triangles can we make? N minus 2 triangles. We have n sides, n angles, n minus 2 triangles that can be made. Okay. Each interior angle, again, without looking at the formula, we can just reason this out. If the sum of the interior angles is 720, and there are 6 angles, 1, 2, 3, right? 1, 2, 3, 4, 5, 6 angles. And those 6 angles added together is 720. Since it's a regular hexagon, all those angles are the same. So we can just do 720 divided by 6, which is going to be 105. 120? I don't know what I'm saying. 120. I do know what I'm saying. It's 120. Okay, but we could also look at the formula if we wanted. Okay, the formula clearly states n minus 2 times 180 divided by n, which basically means the sum of the angles, right? 720 divided by the number of angles that there are. So we found, well, we can just substitute it. We'll plug in for the whole thing here. Right? We found that n minus 2 times 180 was 720. So this means 720. This whole thing was equal to 720. N is 6. So 720 divided by 6, which gave us 120. If you want to plug the whole thing in, that's fine. If you want to do 6 minus 2 is 4. 4 times 180 is 720. 720 divided by 6 is 120. That's fine. But we can go straight to 720 divided by the number of angles that there are. The sum of the interior angles divided by the number of interior angles is how much each interior angle, the measure of each interior angle. Okay. Sum of the exterior angles, this is the easiest one. Here we have 6. So 1, 2, 3, 4, 5, 6 exterior angles. If we put them all together in the middle, a point in the middle, it would look something like this. Oops, not like that. Oops, I'm missing, and then this one. All right, well, what do we know this is? We know this is a circle. We know that's 360 degrees. So no matter what polygon you have, the exterior angle, the sum of the exterior angles is going to be 360. Okay? So again, here's our formulas. Right, and we can clearly see on our half sheet, our notes, that the sum of the exterior angles of all of the polygons is 360. Okay, the last one here asks for the sum of each exterior angle. And again, it's intuitive. We have the total, all 6 of them added together are 360. The sum of them is 360. There are 6 of them, so we divide by 6. Okay, 360 divided by 6 is going to give us 172-ish. Right, 72. Maybe. No. 60. It's going to give us 60. Six goes into 36 6 times. Add the 0, 60. Okay, and again, the formula for that was 360 divided by 9. Okay, so those were the 4 formulas we used. So I'm going to leave the formulas, but I'm going to erase the rest here. And we'll do number 2, which is the 47 gun. All right, the 47 gun has 47 sides and is 47. If we're trying to find the sum of the interior angles, okay, we can just use the formula. So 47 minus 2 times 180, meaning we can make 45 triangles out of a 47-sided polygon. Okay. 47 minus 2 is 45. 45 times 180. I don't know. I'm using the calculator. A little ashamed of myself, but I'm tired. Should be doing it by hand. 8,100. Should have remembered that too. Each interior angle, so we have to take the sum of the interior angles and divide by how many angles there are. So how many angles are there? There are 47. 47 sides, 47 angles. So we divide by 47, we get 172.34. So that is each interior angle. Okay, we could also put it in the equation if you want to. 47 minus 2 is 45. 45 times 180 is 8,100. And then 8,100 divided by 47 is going to give us 172.34. Sum of the exterior angles is going to be 360. It's always 360 for every polygon. And then to find each exterior angle, we have to divide by how many exterior angles there are. How many exterior angles are there? The same number as interior angles. So we do 360 divided by 47, which should give us 7.66, I believe. Let me check. 7.66. Yep, and that makes sense because these two should be supplementary. They should form a linear pair. Just to demonstrate on the hexagon, again, we found that it was 120 and 60. The interior angles were 120 each, and the exterior angles were 60. The interior angle forms a linear pair with the exterior angle. The interior angle forms a linear pair with the exterior angle. So those two should add up to 180. Two more examples, same type of problems. If you weren't in class, I would stop the video, try them on your own. If you were in class, you just want a refresher, then that's fine too. Okay, so octagon, n is going to equal 8. 8 times 2, or 8 minus 2 is 6. 6 times 180, right? So it's going to equal 1080. 1080. So the sum of the interior angles of a octagon are 1080. Okay. Again, where this comes from is the fact that we can make 6 triangles. The sum of the interior angles of each triangle is 180. 6 times 180 being 1080. Okay. Each interior angle, again, we can plug or substitute in 8 right back into this equation. 8 minus 2 is 6. 6 times 180 is 1080. 1080 divided by 6 is 150, 60. Let's look. 1080 divided by 8. It's 135. Or we can just say, hey, look, we have the sum of the interior angles is 1080. So it's the sum of the interior angles. We have 8 interior angles. Since it's a regular polygon, all 8 of those angles are the same. So we can just divide by 8 and we get 135, right? 1080 is what the numerator of the formula represents. The sum of the interior angles divided by the number of interior angles that there are. Sum of the exterior angles is going to be 360. Each exterior angle, our formula says 360 divided by n. So we basically take 360 and divide by the number of exterior angles. So the number of exterior angles here, again, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Those 8 added together are 360. So we have to divide by 8 to get each one individually. 360 divided by 8 is going to be 45. 360 divided by 2 is 180. 180 divided by 2 is 90. 90 divided by 2 is 45. So that is the octagon. The 32gon, in 32 sides, 32 angles. Okay. So we can tediously make 30 different triangles here. That'd be pretty tedious. Go around the whole thing. So we just use our formula. N is 32. Number of sides, 32 sides, 32 angles. So 32 minus 2 times 180. 32 minus 2 is going to give us 30, which is the number of triangles we can make. 180 represents the sum of each of the angles in each triangle. So we have 30 times 180, which I believe is 5,400. 3 times 18 is 54. Add on 0, the 2 zeros. 5,400 is the sum of the interior angles. How many interior angles are there? There are 32 interior angles. So 5,400 divided by 32. 168.75. Sum of the exterior angles, if we could draw all the exterior angles on here. Right, which is kind of ridiculous. Right? All those would add up to 360. And the last one asks for each exterior angle, but we have to divide by the number of angles that there are. How many angles are there? There are 32 angles, so 360 divided by 32, which is going to be 11.25. Again, supplementary, right? The interior angle and the exterior angle are going to be supplementary. Two more problems. This one, a little different style, but same concept. And if you weren't in class or you missed this, I would try these on your own, but what we're looking for is to find the value of A, the value of B, the value of C, and the value of D. The value of A, the value of B, the value of C, and the value of D. So probably should try to stop the video and try that on your own first. First thing we want to look at, though, is A, an interior angle or an exterior angle? Well, it's an interior angle. How do we find the measure of each interior angle of a polygon? Well, we use the formula n minus 2 times 180 divided by n. How many sides does this polygon have? This polygon has 5 sides. 5 sides or 5 angles. So we just substitute it in. 5 minus 2 times 180 divided by 5. 5 minus 2 is 3. 3 times 180 is 540. 540 divided by 5 is going to give us 108. So we know the value of A is 108. We also know all of these are 108. Is B an interior angle or an exterior angle? It's an exterior angle. What do we know about exterior angles? Well, we know they're going to, all of them are going to add up to 360. So how many exterior angles do we have? We have 1, 2, 3, 4, 5. Okay, so if the sum of the interior angles is 360, and we have to divide by the number of exterior angles that there are, which is going to be n. Okay, so that's our generic formula. In this case, n is 5. So 360 divided by 5 is going to give us 72. And again, that makes sense because these are a linear pair. They're supplementary. C, is it an interior angle? First of all, let's find what n is. Well, we have 7. 1, 2, 3, 4, 5, 6, 7 sides. So we have 1, 2, 3, 4, 5, 6, 7 angles. So n is 7. C is an interior angle, so we can use the formula to find the measure of each interior angle. Be careful not to just find the sum of the interior angles. C is not 7 different angles added together. C is just one singular angle. So we have to make sure we're picking the formula for each interior angle, which is n minus 2 times 180 divided by n. And in this case is 7. 7 minus 2 is 5. Okay, 7 minus 2 times 180 divided by 7. 7 minus 2 is 5. 5 times 180 is 900. 900 divided by 7. $128.6. It's a little bit off the screen there. 128 point. Let me write it below. 128.6. Okay. Formula for our exterior angle is 360 divided by n, because the sum of all 7 exterior angles is going to be 360. To find each individual exterior angle, we have to divide by the number of exterior angles that there are, which is 7. Okay. 360 divided by 7 should give us 51.4. So again, this is 128.6. That means this one's also 128.6, 51.4, and look at that, our two answers are supplementary. So if you can do those 6 problems, you got the notes all filled in on the half sheet, you should be good for the Thursday, the quiz portion that has to do with Polygon's angles, angle sums, and the interior angles and the exterior angles.